Alright, this video is for lesson 11.4. This is our last new topic of unit 11. This time we will be focusing on a particular type of distribution which is called a normal distribution. So last time we kind of talked about that a distribution could be symmetric or it could be skewed, or really sometimes it's just all jumbled up. But today we're going to be talking about a specific type of distribution, which is called the normal distribution. So here are some small pictures of some examples and some counter examples of normal distributions. So for each pair, the one on the right represents a normal distribution. The one on, I know my right from left. The one on the left is a normal distribution. The one on the right is not a normal distribution. So as you look at these different examples and counter examples, you should be able to start to recognize some of the things that makes a distribution normal. And those things are that for a normal distribution, the mean and the median and the mode are actually all the same. And they are located right at the center. So it's symmetrical about the center. The right half and the left half look identical. They're mirror images of each other. 50% of the data is less than the mean. 50% of the data is greater than the mean. And the total area would, of course, represent 100% of your data. So normal distributions are kind of important because a lot of things actually follow a normal distribution when you start to analyze them. So things like the heights of people tend to be normally distributed. That, of course, you'd have to have some control there. You'd have to have like male and female separate. But the height, for example, of all adult males would be normally distributed. When you have machines that are producing things, the sizes of those machines might vary a little bit, but the sizes would be normally distributed. If you look at errors that are made in measurements, if you recorded all of the errors, they would tend to be normally distributed. Blood pressure is normally distributed. Really, a lot of things that have to do with animals tend to be normally distributed. So we're going to first look at histograms, and then in a minute we'll switch to the normal curve itself. So first of all, we'll look at this histogram. It says bar graph, it means histogram. The histogram gives the weights of a population of female brown bears. The red curve is showing you that symmetric shape. And the mean for our brown bear weights is 115 kilograms. So the little numbers here beneath the bars, this is saying that this bar represents all of the bears between 100 and 109. The bar next to it would represent 110 to 119 and so forth. Okay, so let's look at our first question. First question says, about what percent of the female brown bears weigh less than 100 kilograms or more than 129 kilograms? So, I don't know if you noticed, but our y-axis over here is giving us percentages. So, weights less than 100 kilograms, we're talking about, we're talking about the bears that weigh less than 100. We're essentially talking about this bar here and this bar here. So it looks like the first bar would be about 5%, and maybe we'll call this one 1%. It looked like there was a little something there. So far, 5% and 1%. But then we also want to think about the bears that are more than 129 kilograms. So that would be the ones that are 130 to 139 and the ones that are 140 to 149. So it looks like we have another 5% and another 1%. So altogether, about 12% of the bears are less than 100 kilograms or more than 129 kilograms. The second question says, what percent of the brown bears should weigh less than 115 kilograms. Well, remember the mean of our data was 115. That's the center. And for things that are normally distributed or approximately normally distributed, we would expect 50% of our data to be less than that mean, and then the other 50% will be greater than 115. Okay, next question says approximately what percentage of female brown bears weigh less than 120? So I'm going to erase this and see if I can find 120 on here. So 120 is right here. So less than 120 is talking about all the bars to the left. So it looks like we've got this first bar has a height of, I don't know, maybe 42% approximately. This bar here is looking like to me about 23%. And then this bar here is 5%. And there's like a little teeny bar here, we're going to just call that 1%. So 42 plus 23 plus 5 plus 1, that's 60, 71%. I'm adding in my head, so don't hate on me if I did it wrong. 60, 71. I think it's right. Okay, next question says the standard deviation of the weights of a sample of female brown bears is 10 kilograms. Approximately what percentage of the female brown bears have weights that are within 1.5 standard deviations? Well, the standard deviation is 10, so 1.5 standard deviations would be 15, 1.5 times 10. So that range that we're talking about, it needs to be within 15 of the mean of 115. So we're talking about the bears that are between 100, so that would be 15 less than 115, and if I add 15 to the 115, it's 130. So we're looking at what percentage of the bears are between 100 and 130. And that means that they're within 15 of 115. So that would be from here to here. It's those three center bars. So if we go from left to right, this first one looks to be about 23%. The middle one looks to be about 42%. And this far right one here would be about 23%. Wow. So if we add that up, we get 65, 88%. So we would expect 88% of the bears to be within 1.5 standard deviations of the mean. All right, so I'm going to skip this one in the video to keep the video shorter. I will fill in the notes on this one and post them on the website if you want to look at them. I'm going to go to the next thing though. So we've been looking at histograms, sort of more like the one on the left there. As your sample size gets larger and larger and larger, or as you decrease the size of your bars, due to the law of large numbers, it's going to start looking more and more and more like a curved shape instead of as separate bars. This is called, when it's this curved shape, a normal distribution or a normal curve. It's continuous, it's symmetric, it's bell-shaped, and that's what we're going to be focusing on the rest of the lesson. Oh, there's a joke of the day. So one of the characteristics of the normal distribution is that within certain number of standard deviations, we know how much data or what percentage of the data is within those bounds. So within one standard deviation of the mean, for a normal distribution, you will have 68% of the data. If you're talking about within 2 standard deviations, that is going to encompass 95% of the data values. And within 3 standard deviations, you're going to have 99.7% of the data. And that's going to always be true. That's a characteristic of a normal distribution. And it's called the empirical rule. So if you sort of further subdivide it, you can see that that 68% that is in the center, 34% is on each side of the mean. And those two added together give you this center 68%. 13.5% is what you have here. And then, of course, you have another 13.5% on the other side. It's completely symmetric. And the whole tail would be 2.5% total. If you add these two together, it's 2.35% here, and then the other 1.5% is outside of the 3 standard deviations. So sometimes seems weird to look at this at first, but we'll be using it to answer some questions, and you'll get to know these percentages really well. You do need to know these percentages on your test, and you will not be given them, but as you're practicing, you'll totally just memorize them naturally as you use them. So we're going to first start just fitting our data to a normal curve, and then in a minute we'll use our normal curve to answer some questions. So the first one says, population of male European eels, a mean body length is shown and the standard deviations are shown below. We want to sketch the normal curve showing eel lengths at 1, 2, and 3 standard deviations from the mean. So it tells us that this little guy is the mean length. So the center is where the mean goes, and it's saying that that's a 15.7. Well, to decide what value is going to be at these other standard deviations away, we just need to, we'll figure out what the standard deviation is. So this guy is 1 standard deviation above the mean, so that goes here. And this guy is 1 standard deviation below the mean, so this goes here. Well, if you fill those 2 values in, you can see that the amount of the standard deviation is 2.8. And so we add 2.8 to get here, we subtract 2.8 to get to the 12.9. So to fill in the remainder of these, we just have to keep that same pattern up. If we add another standard deviation, I lost my calculator. If we add another standard deviation, we will get 21.3. And if we add another standard deviation to get to this bar, that would be 24.1. And we can do that same thing on the other side, but we're subtracting. So we subtract another standard deviation to get to 10.1, subtract another standard deviation to get to 7.3. So we've now fit it to the curve, and we can answer questions at this point, like we know, for example, 50% of the fish are between 12.9 and 18.5 inches long. Let's see, I have one more for you to do, is the female ones. In this case, I'll do part of it here. 21.1 was the mean of the data, and then we would count out by 4.7 in this case. And you can finish that one up. So how do the mean and the standard deviation affect the shape of the normal curve? Well, remember, they're always going to be symmetric. They're always going to be a single peak. They're always bell-shaped, but that doesn't mean they all look the same. These 3 that are shown on your screen all have a mean of 3, but they have different standard deviations. This one has a standard deviation of 0.5. This one has a standard deviation of 1. This one has a standard deviation of 0.25. So you can see that larger standard deviations make this curve more spread out. Smaller standard deviations like this one make it tighter. So the standard deviation affects how spread out the bell shape is. Standard deviation is a measure of spread. So it's telling us how wide that bell is going to be. These three all have the same standard deviation, so they're spread out exactly the same. They have a different mean. So how the mean affects the shape of the normal curve is that the mean tells you where the peak is located. So this one had a mean of 1, this one had a mean of 2, this one had a mean of 3. Okay, so now we're going to use the percentages, and you, again, will not have this given to you on the test. You have to know it. But as long as you practice and do your homework, you won't have any problems memorizing this. So let's look at one. The height of the adult American males are approximately normally distributed with a mean of 69.5 inches tall. That's our mean that goes in the center. The standard deviation is 2.5 inches. So we're going to count out by 2.5s. So this would be 69 plus 69.5, sorry, plus 2.5. This would be 72 inches is one standard deviation away from the mean. And I like to go all the way out in one direction before I go in the other. So another standard deviation would be 74.5 and finally 77. So this would be 3 standard deviations away from the mean. And then we could do the same thing in the other direction, but now we're subtracting the 2.5. So this would be 67 inches, 64.5 inches, and 62 inches. So now that we have put our little number line there, at the bottom, we can answer these questions. It says, what percent of adult American males are between 67 and 74.5 inches? So we are talking about between 67 and 74.5 inches. We're talking about these 3 sections of the normal curve. Well, if you look at your empirical rule, we know that this section and this section are both 34%, and this section is 13.5%. So to get our answer, we just need to add up those percentages. .5% are within 67 and 74.5 inches. Second part, in a group of 2,000 adult American males, about how many would you expect to be taller than 6 feet? So this time we are talking about the ones that are taller than 6 feet, which is 72 inches. We're thinking about this tail over here. Well, sometimes it's useful when you're doing normal distribution to think about that each half is 50%. So it looks like this tail over here, it would be 50% subtract this 34% because we aren't including that one. So that would be 16% would be taller than 72 inches. And we're wondering how many out of a group of 2,000 that would be. Well, 16% of 2,000 is 320 men. So out of a group of 2,000 men, we would expect about 320 of them to be taller than 72 inches. Okay, we'll do one more real quick. The scores on the Math 3 final are approximately normally distributed with a mean of 150. That goes in the center. That's where the mean is located on a normal distribution. And the standard deviation is 15. So we're going to count out by 15s in both directions. if we do that, we get 165, 180, 195, and in the other direction, 135, 120, 105. So let's answer the questions now. What percentage of students scored below 180? Well, that would be all of these. Well, this portion of it over here is 50% because each of the halves is 50%. So we for sure include them. Plus we have another 34% here. Plus another 13.5% here. So we have 50% plus 34% plus 13.5%, and we get that that would include 97.5% of the students. Next question says, if 250 students took the final, approximately how many scored above 135? So we're looking at this time above 135. Get rid of, whoa, whoops, I don't want to get rid of that. I want to get rid of the red stuff. Maybe it would be easier to erase. Oh, I erased my numbers. Good going. Okay, so we're looking for above 135. So in this case, we're looking for these ones here. Well, this portion of it would be 50% plus an additional 34%. That's 84%. And we want to know the quantity of students. So 84% of the 250. We just multiply that to find that we would expect 210 students to score above a 135 on that test. Okay, so that's normal distribution in a nutshell. If you need some help with that, please come in before school, after school, or at lunch, and I will help you with that. This is really our last topic of the unit, so make sure that you are on top of that all because we're going to be testing soon. So just let me know if you need help. Thanks.